Hello friends, welcome back to my channel. In this video, we shall learn the concept of refraction through lenses. Already we have learnt about the concept of refraction in the previous video. The link is given in the description box. Please check it out. Before that, if you are new to the channel, do subscribe and press the bell icon so that you will get the notifications of all the videos we upload here related to TET exams, Central TET and GPSTR exam, mainly of maths and science concepts. We shall move to the video now. Come, let's learn about refraction through lens. A lens is a transparent refracting medium bounded by either two spherical surfaces or one surface spherical and other surface plane. So I hope you are familiar with the lenses. So there are two types of lenses, convex and concave lens mainly. Convex lens converges the light ray which falls on it. Hence, convex lens is also called as converging lens. Whereas concave lens diverges the light ray which falls on it. Therefore, concave lens is also called as diverging lens. Let's move into technical terms related to lens. I have taken an example of convex lens here, and from one part of a lens extended and drawn a circle, and from this part of the circle there is a small circle drawn, imaginary circle. And we shall learn the important related terms. First one, center of curvature. The center of the sphere whose part is the lens surface is called the center of curvature of that surface of the lens. So here we have taken this lens, and if you consider this as a circle, the center of the sphere, for this sphere, this is the center, whose part is the lens surface. For this circle, little part is the lens surface. So this is the center of curvature for the imaginary circle we have drawn. Okay. So C1 is the center of curvature for this first circle. The same way for the second circle. So C1 and C2 are the center of curvatures of the convex lens we have taken here. Next, radius of curvature. To explain this time we have considered the concave lens. You can compare this with the other diagram of convex lens also. Radius of curvature. The radius of the sphere whose part is the lens surface is called as radius of curvature of that sphere. So here you can take the convex lens, and from the part of a lens we have drawn an imaginary circle, and from the other part also imaginary circle is drawn, and these two are the center of curvatures C1 and C2 for the respective circles we have taken. So the radius of the sphere whose part is the lens surface. For this sphere we have taken the radius. If you draw the radius, for example, small circle, P1 C1 is the radius of this circle, and for this circle little part is the lens surface. Hence P1 C1 is the radius of the circle. But when we compare this P1 C1 value with the C1O, C1O is little extra, additional. But for a thin lens, if you consider, this value from this lens surface to till the O will be very minute comparatively. Hence we can neglect the value and we can compare, or we can equate. For a thin lens, the radius of the sphere is nothing but the radius C1 up to O. Okay. Hence we can write for a thin lens P1 C1 is equal to O C1. Okay, for a thin lens only. Next, principal axis. It is the line joining the centers of curvatures of two surfaces of the lens. So here we know the center of curvatures of two lenses, C1 and C2 are the center of curvatures, with the line joining these two centers of curvatures and extending the line on either sides. This is the principal axis of the lens. In this diagram, the lines are drawn between this C1 and C2 points, or joining this C1 C2 points. Hence, C1 C2 is the line, okay, for the principal axis. And moving to the next term, optical center. Optical center of a thin lens is the point on the principal axis of lens such that the ray of light directed towards it passes undeviated through it. Means through this optical center, if any ray of light is passing through, if it is a thin lens only, okay, which is undeviated, we can consider. So that point is the optical center. So in this diagram, the optical center is here, O, for this convex lens. In case of concave lens also, we represent it as O only. You can look into that diagram, okay. So any light ray which is falling or passing through this optical center will pass undeviated, means without deviating, without undergoing refraction, it will emerge out, okay. So there may be multiple choice questions, okay. So how does that light ray emerges out when it passes through the optical center of the lens for a thin lens? So it passes undeviated. You can draw one line like this, from any side you can draw the line which will pass undeviated through this. Next, focal length. The distance of focus from the optical center of the lens is called its focal length. So to explain this focal length, we have taken a base ray diagram. Here the lens is, and you can draw an axis which is passing through the optical center here, and from this O point till the first focus F1, we can call it as, this distance is known as F, focal length, the distance from the focus to the optical center. And meanwhile, we shall also learn about the focal points of this lenses looking at this ray diagram, which is important. Principal foci. Foci is the plural form of focus. Here in this diagram you can observe, in case of convex lens, we have taken F1 point here and then 2F1. On this side F2 and 2F2. Here the points F1 and F2 are the foci, principal foci. It means the light ray enters through the lens from either sides. Either this side also light ray can enter, on this side also, because both the sides are refracting surfaces, are transparent ones, and therefore the lens has two principal foci. If the light ray is falling from this side and we consider this F1 as the principal foci, focus, we call it as F1 is the focus point, okay. So on either side of the lens we have here one focus, and this side there is the focus, okay. So F1 is the first focus, F2 is the second focus in case of convex lens, okay. In concave lens it changes as we move into the ray diagrams. Again I will be explaining that now. So if a light ray is originating from this focal point, if it starts from here, it will pass up to the lens here and then moves parallel to the principal axis. If a light ray is entering as parallel to the principal axis in the beginning, then it will pass through the focus point, okay. So in case of ray diagram, we will take up, because we are focusing on the important points, these points in between I will be explaining in between of the ray diagrams, okay. Now we shall move to the ray diagram to calculate the position of object and image, and before that, this is the base ray diagram for all the type of position and object of the images. What you should do, you have to draw a base line, straight line, then you can draw the respective lenses, either concave or convex lenses, and from the midpoint here of the lens you can draw an bisecting line, bisector, and where this two bisector and the principal axis passes through, here optical center O you can take it. Then if it is a convex lens, F1 to the left side and F2 here right side, then the other side 2F1 and 2F2. In case of concave lens, F1 on the right hand side as we view, and left hand side becomes the F2, and respectively 2F1 and 2F2 also will change. And if you take an object like this, the first ray, remember the first ray should be from the tip of this object straight, it should pass through the optical center. Okay, in case of object is between these points. Okay, now if the object is at infinity, the diagram will be different. That we'll be discussing. And one more point we have to discuss. U is the distance of the object from the optical center where the object is placed. Either you can place the object here, F1, F2, between these two, anywhere. Wherever you place the object, the distance between the optical center and the object is distance of the object. It is represented by U, and V is the distance of the image, the other side, from the optical center till where the image is formed. Okay, from this optical center till where the image is formed is the distance of the image formed. Let's move to the ray diagrams. Already I have drawn in order to explain it, otherwise it will be time consuming. So the first point, when the object is at infinity. In case of a convex lens, we are going to learn this ray diagrams. Then we will move to the concave lens. So here, when the object is at infinity, that means U distance of the object is infinite. Infinity you have drawn, and this image formation we'll see later. First, how do we draw this ray diagram? You will draw the ray diagram, basic principal axis, then the convex lens, and then draw this bisector line with a dotted line and then mark optical center. Then how to mark this F1 and F2? From the center, this F1 must be equal to F2 value, wherever OF1 is equal to OF2 you take. You keep your scale and you can draw either 2 cm, 3 cm, fixed to one distance, okay? Any value, either 2.5 or 3 also you can take. Normally you can take, and you can cover up in this page like this. So I have taken 3 cm. From O, 3 cm. From here, 3 cm. The other side also, from O, 3 cm. From F1 to F2, sorry, to F1, again 3 cm. So 3 cm, 3 cm, 3, all the sides. Clear? And then next, the first ray diagram we have to draw, as we told. First line must pass through the optical center from the object. But here the object is at infinity, hence you can just draw a straight line. Then how will the next ray passes? We consider the next ray which will pass through F1. In case of object is at infinity, F1, and till the center line, dotted line, it will have to pass straight. Then after passing through this, you have to draw this line, take a diversion. It has to pass parallel to the principal axis, like this, straight parallel. And where these two both rays cut, there will be the image formed. Here these two intersect and image will be inverted like this. So where does the image formed? The image is formed at focus point. At F2 point, image is formed. You can mention as focus also. So when the object is at infinity, image will be formed at second focus, or F2 you can mention. For the convex lens, what is the nature of the image formed? The image is real image, and it is inverted image. It is highly diminished. Suppose you are focusing a far away object, infinite object, maybe sun you are focusing, and this will be, you can get the image, a real image. Actually real image will be always inverted, and it will be diminished image. Okay, and it is used in case of burning glasses. You would have played with this burning glass when you were small, or you would have learnt about that. So applications of this is in case of burning glass, and in even camera lenses also we use this type of position of object and image place rule. Clear? So easy diagrams only. One diagram if you practice thoroughly with all the proper measurements, then later you can draw this. On moving to the next one, when the object is beyond 2f1. Okay, so what do you mean by that, beyond 2f1? Here we can observe that f1 to f1, beyond this means before that only, prior to that. So here you place the object is a straight object. You can just draw like this, arrow mark facing upward, and all remaining base diagrams, principal axis, f1, f2, 2f1, 2f2, everything with the lens. So properly you draw the lens before, and this should match with this. Okay, if you draw the small lens, then you will not get the refracted ray here. Okay, then after drawing this object, from the tip of an object, one line straight you draw, which is passing through the principal axis here. With the red line I have marked. The next line, in this case, the next line should pass parallel to the principal axis first, and then it should pass through the focus point. Remember, just now, as I was telling you before, through the convex lens, if a line is passing, entering the convex lens parallel to the principal axis first, if it is, you see principal axis here, this line is passing parallel to this, parallel. After entering the lens, after undergoing refraction, it passes through the focus point. So through this it has to pass. Where these two lines intersect, there you draw the image, draw an inverted image, okay? Arrow mark is down. If you mark this object as A and B, this side will be your A dash and this is your B dash, okay? Clearly you have to mark it down. This might be asked for 2 marks. There is a question in bioscience question paper, model question paper of GPSTR exam 2022. So this is how to draw this, and don't forget to draw this arrow mark. Here there is an arrow mark and here also, and mark properly with optical center, and this is the deviation which takes D you can represent. So when the object is beyond 2f1, we call that is u value is greater than 2f value. So this is 2f, up to here is 2f, and value is greater than 2f, u value. Then image is formed. Where does the image is formed? Image is formed between f2 and 2f2. f2 and 2f2. And what is the nature of the image? It is real, it is inverted, and it is diminished. Comparing with this object, it is diminished value. And application of this, uses of this type of arrangement, it is used in camera lens. If we want to get the image of a tree, we are able to get a diminished image of a tree, right? And when the object is not too far, okay, nearby objects, we can get this kind of images. Cleared? We shall move to the next one. When the object is at 2f1, that is, you can observe here, the object is at 2f1. f1 is here, 2f1. And the remaining all basic diagram you have to draw. So this side you can observe from the optical center. I have taken f1 and 2f1 below, and this is above. It doesn't matter, anywhere you can draw. But if you write it down here, it will be clumsy. That's why I have taken it up. That's it, okay? Then base diagram. Take the object exactly at 2f1. 2f1 is the place here. Draw the object. Then one line which is passing through the optical center, straight, you draw the line. Just first line is over. Next line, you take this line which is parallel to the principal axis, then which has to touch this dotted line of the lens, midline, bisector line. Then it has to pass through the focus. And where they both bisect, there you draw the image. In case of convex lens, draw the inverted image. Comparing with this size of the image, you can see here, almost same, yes. So, and then you take A, B here, and inverted A dash and B dash. And don't forget to write optical center and arrow mark, all this. So, when u value, where is the u value? The distance between the optical center and the object. Okay, so this is u, that is 2f, twice of focal length, 2f. And where is the image formed? When the object is at 2f1, image is formed at 2f2. Okay, here is the image formed, 2f2. And image, nature of the image is real, inverted, and same size as the object. So this kind of arrangements is used in application of this is in terrestrial telescopes they use. Okay, application of this is in terrestrial telescope. They may ask a question, draw a neat label diagram of a convex lens where the real image, the size of the image formed is same as that of the object. Then you can draw this diagram. We shall move to the next one. When the object is between f1 and 2f1, you see here f1 and 2f1, object is between this f1 and 2f1, and f value is, f is less than u, and which is less than 2f value. This is less than 2f value. 2f is here, this is less than f, and f is still less than u value. Here f is, and we shall draw the base diagram first, then one line from the image which is passing through the optical center, then next line for the, here it is marked with black, which has to pass parallel to the optical center, then it has to pass to the focus point, and where they both intersect, there you draw the image. Okay, I think by this time you would have got this. If you have already learned this, just to recall, okay. And where they both intersect, there you draw an inverted image. You can see a B and A dash, B dash here, and remaining diagrams and all marked down. Where does the image is formed? Image is formed beyond 2f2. So when the object is between f1 and 2f1, image is formed beyond 2f2 on the other side of the lens, the other side. And image is real, inverted, and it is magnified. You see, it is magnified, bigger. So where does this applied? This is application applied in case of cinemas and slide projector. But in slide projector, they won't put the image as it is to get the inverted. In the beginning only, if it is inverted only, then you will get inverted image of this inverted image as proper erect image. They will get it. Okay, care is taken to insert the projector slides in the projector. Okay, so this is the application of the above setup. On moving to the next one, when the object is at f1, that is u is equal to f value. Here object is at f1, exactly on f1, and draw all these base diagrams as usual. Then be careful while drawing this line, and the object you have drawn, AB is the object. First line, principal axis line, finished. Next line, parallel to the principal axis till this bisector line. Then it has to pass through focus point f2. Then with this, if you extend, they both will never meet. That will lead to infinity. Okay. Then AB is the object. Only A dash you can get here, you can draw, but B dash you don't know where it is, the other side. How large the image is, we don't know. It is going up to the infinity. So when the object is at f1, image will be formed at infinity, and image will be real, inverted, and highly magnified. Very, very big image will get. And application is, it is used in application of collimator of spectrometers. We find this setup. Okay. And moving to the important point here. Next, when the object is between the lens and the focus, that is, here you see this is the lens and the focus point here. Even the object is placed between the lens and the focus, a chota object here, and u value is less than f value. And where the image will be formed, we'll check it out. First, as usual, forget about this dotted line and all now. In the beginning, draw the baseline as usual. From this point, you draw the optical line passing through the optical center, then take a line parallel to the principal axis, extend this, but this will never meet each other. Where will be the image formed? For this kind, you have to draw it back, extend or trace it backward. Okay, from this point here, put a dotted line. Again, this two line, put a dotted line, trace it backward. Where these two lines meet, there you draw the image, but image will be virtual image, and it is erect and upright. It is not inverted image, it is virtual, erect and upright image. You see, the arrow mark is upward only. If A, B are here, this will be A dash and B dash. And where the image is formed? Behind the object only. The image is formed on the same side of the lens. If this side is the object, same side of the lens, image is formed. So image is formed on the same side and behind the object. So where do we find this kind of application? We find this in case of magnifying lens. Okay, normal convex lens you can use as a magnifying lens. When you suppose you want to read this page, you bring a magnifying lens here, you can see the image object will be here. Behind the object must be image formed, magnified image. Hence only you are able to read this. Then application is, it is used as a reading lens and it is used in the magnifying glass, or it's a simple microscope also. Okay, so this is the beautiful explanation. I think this question is asked in the GPSTR 2022 model question paper. Okay, you can refer the previous year question papers also. Is it clear now? I hope it is clear. I'm moving little fast because to cover up this, I know you all are preparing for the exams, and then you can have a glance of this, you can have a quick revision of this. That's it. So in short, writing all these points in one pic, here you can write them like this. You can have a glance of this, which is already we have explained. You can take a screenshot of this and you can prepare before entering the exam hall. You can just have a glance and you can move. We shall move to the next one. In case of concave lens, the image formed in case of a concave lens, it's very easy. For concave lens, only two types of images are formed here for the respective position of the objects. Let's learn about that now. Remaining base diagrams as usual you will draw when the object is at infinity. So we shall learn about the image formed later. First you have to draw the baseline, that is a principal axis, then mark from the lens. First you draw the lens of concave lens, optical center, bisector. Then be careful while writing the f1 and 2f1. This should be right side as we view. Okay, f1 2f1, and the other side will be f2 and 2f2. And the first line, since the object is at infinity, first line which has to pass through the optical center, straight line, this black line which represented. Then next line which is marked in the red, it has to pass like this, only slant till it meet the point here, this dotted point. Take parallel to the principal axis, and on producing this line backward, where this extended line meets the line which is passing through the optical center, there will be the image formed. And image formed, you can take a virtual and erect image, not inverted image. This should be a dotted line. Okay, so this is the image formed, and A dash B dash is the image. Remaining all you know how to draw this baselines, and optical center also you please mark it. Okay, so when the object is at infinity, image is formed at the second focus. For this concave lens, first focus is here, second focus is here. So image is formed at the second focus, and the nature of the image is virtual, erect, and highly diminished image. And this is applied in case of Galilean telescope. In case of second diagram, when the object is at any finite distance, it means the object distance is between the infinity and optical center, any distance. Either you can place it here on 2f2, between this 2f2 and f2, anywhere you can place the object. But when we take all these images here, it will be difficult to show in the diagram. That's why we have taken little far beyond this 2f2. You can take anywhere, but when we draw, it will be a clumsy diagram. That's the reason I have taken this one here. Okay, so how do we draw this when the object is at finite distance? We have drawn the object as usual with the base, all the diagrams. Then one line has to pass through the optical center. First line is over. Next line, this line has to pass parallel to the principal axis. Same in case of convex lens also, we have second one. Other than the infinite distance, second one we have taken a parallel line. Then it has to deviate like this, it will, and produce this line backward, where this produced backward line meets the line which is passing through the principal axis. There will be the image formed. Here you can observe a chota image, very small here, where these two intersect. A dash and B dash is the image. Here AB is the object formed. Okay, dotted line you can express. And the image is, when the object is at any finite distance between the optical center and the infinity, image is found between the lens and the focus. It will be between these two only, always between the focus point and the optical, between the lens, this center, between this only. This kind of setup is used in spectacles, especially those who are suffering from the short-sightedness, and for third person, to remove the short-sightedness and to make the proper sight, they use this kind of setup. So this is about the concave lens. So this for these two images they have drawn in a short notes, and the object is at infinity, whereas the image is formed, nature of the image, and where it is applied. Also, in case of concave lens, you can take the screenshot and save it and learn for further reference. Okay, so I think we have covered the important points in the ray diagrams. Okay, in the following classes we shall continue with a few more topics of optics, maybe about scattering of the light, and few topics are given. So how much ever I can help you out with before the exams, I'll continue the classes. So if you like the video, don't forget to give a thumbs up. Okay, in the following classes we'll try to take a few maths classes also, as I read your comments, and I make all the ways possible to give out the best from my side. Okay, keep preparing for the exams, and you have to prepare more these days. Revisions are very important. You would have already learned few concepts earlier, which is known concepts, because most of your preparing for these exams might be teachers only, right? And you would have learned the concept, but revision is very, very important at this point of time. Spend some time, have a just glance of the known concepts which already you would have learned. Okay, if you revise, that will be helpful. Make short notes and revise it in this very crucial time. Prepare for the exams. Okay, thank you for watching.